G'day everyone, welcome back to Harper's Shed. It looks a little bit different. It's because we're not actually in my shed, we're in my dad's shed. So technically still a Harper's Shed. Right, this time we're going to get back onto some engine work for the RX-7. So yeah, sit back, relax, I'll take you through what we're going to get done today. Okay. Now you're not seeing double. What you're seeing is a replacement rotor. So, straight up, before we get into anything, I have to give a massive, bottom of my heart thank you to Alex from Redline Rotary. He searched high and low for that rotor for me, and he nailed it. It is perfect weight, down to about 3 grams of my matching rotor, or my old rotor. And on top of that, it's already been machined for 3mm seals. And on top of that, it's already been machined for race clearance. So the width of the rotor's been taken down where it needs to be for higher RPMs and higher load. He smashed it. Every time I ring him up, he's more than happy to talk, more than happy to give me specific information. So I don't know where I'd be right now if he didn't answer the phone. I can't recommend him highly enough. He's been great to deal with. As I said, wealth of knowledge, and he'll help. Finally found someone who'll help, and he definitely will. So I'm going to leave a link to his website down in the description. If you need anything, give him a ring. He's more than happy to answer the phone. I paid full price for the rotor, so I'm not being paid to say it. I just, it's the opposite to what I said in my other video with one person. So anyway, he's been really good. Let me show you what he sourced for me, and we'll get moving forward with that. So again, that's the one he sourced. It has been race clearance, so you can see there's a line there. That's because there's a difference between the thickness of the rotor there and the thickness of the rotor there, and that face itself has actually been taken down. I'll run you through that because I'm going to match it with my rotor that come out of the engine. It has also been grooved for a 3mm seal. Now this has been done by a process called EDM, so it's a wire cut. I'm not going to do that because I don't have access to it. I'm going to do it on the milling machine with a end mill, and I'm going to slot it, and then I'll have to hand finish it. That's not too much of an issue. But this rotor is in perfect condition. There is no marks to speak of. There's no cracks on the stationary gear, on the gear. It's in fantastic condition, and the fact that it is almost perfect matching weight to my old one, that's just icing on the cake. The bearing's pretty ordinary, not an issue. I've got new bearings, so that's fine. Realistically, I probably would have swapped out whatever bearing come in whatever rotor I got anyway. So that's, I can't thank him enough, to be honest. That has turned this from an absolute pain in the ass to something that's finally doable. So my old rotor, I looked and I thought this was detonation. Alex, I sent him some photos, and Alex got back to me and he said, no, that's more than likely just rust marks. I'd agree with that because you can see in the rest of the engine there's grooves, or there's witness marks where there's been water inside. So the rest of the rotor on closer inspection is still in good condition. It's only really that one face that's got the pitting in it, and he said for what I'm doing there'll be no issue with it. So I need to machine these 2mm slots out for 3mm, and then I need to chuck it up in the lathe, and off the gear side I need to machine, so this one is 2 thou smaller in here, and then it's another thou and a half in here. So I'll show you what I'm doing on the machine with that. We'll get it chucked up and squared up and spun out, and that'll be the rotor ready to go. Now I have been allowed access to the surface grinder with my local machinist, and I'm going to go do my plates. Hopefully I can do that this afternoon, so I'll take you along for that. The E-shaft I'm going to put up on the lathe, and I have mic'd it and it's good, but it's got some very light surface rust. So I'm going to put it in the lathe and I'm going to linish those surfaces and bring it back to Schmick. I don't know if we'll get to it in this episode, but I'm going to run you through what you do. Oh, one hand is hard. Oh, that's really good. Yeah, that's all right. What you do to an Eaton M90 to get it to breathe properly. This is part of it here, these lines I've outlined. There's some machining work that's got to go on with this case, and then we've got to pull the pulley off, and we're going to have to make our own up for that, not an issue. As well as some other port work, and I'm going to machine the throttle body. So the throttle body I'm going to take out from the factory size out to 69mm, and then I'll custom make a butterfly as well. So that's enough jabbering. We'll get the mill set up, and I'm going to do a test pass first on a dead rotor, just to make sure it works. Realistically, that's something you should do if you got the option. Always do a test cut. We'll check it, make sure the clearance is good, and then we'll chuck up the actual rotor, get it running. Okay, so this is going to be my procedure for machining the apex seal grooves out from 2 to 3mm. So it's up in the dividing head. The dividing head is squared to the table and then clamped. Now, what I've done is laid a 2mm seal in here, because that's what it is, and I want to ensure that the groove is not skew with the table. So, or it's actually, because the magnetic chuck's up here, it's actually going to ensure that the tool path is not kicked. So that'll be the first one. So what are we on? Are we zeroed? We're zeroed, so we'll just put the auto feed in because it's a bit easier. So it's not quite right yet, as you can see. So each graduation on there is 1 thou. So we are, what are we? Stop that. Ugh. About 2 thou end to end. So, which means we need to go that way. About 1 thou, if it'll move. There we go. So we're about 1 thou. We'll re-zero. Re-zero. And should be pretty close. Lucky to be a couple of tenths bit of that. Now, we know that it is not kicked in any way. Now, the machine itself, I did go through and square the face up already. So we know that the rotor itself is not that way. It's sitting hard up against the jaws, and the dividing head is also square to the table. So we know that the bottom of the groove is going to be parallel. It's not going to be kicked and end up machining more off the bottom of that side than the bottom of that side. The only other thing we have to make sure of is that the groove itself, so the rotor, is sitting in there so that that is completely vertical. Now, how I did that, and bear in mind, if this is off, what it's going to make is the apex seal. See if I can get a better view for you. The apex seal is going to sit skewed. Obviously, that's massively exaggerated. It's going to sit skewed in comparison to the rotor. It's going to be critical, absolutely, but is it critical to get it within 1/10? I don't think it is, especially given that the apex seals themselves are not focusing. They're actually rounded. So the top of the apex seal is an arc. So if the apex seal itself is sitting off ever so slightly in the groove, then it's just going to contact on another part of the arc. Not ideal, but let's get it as close as we can. So how I did it is I come through with the verniers and I measured from a known point, so that point where the side seal ends in the corner seal groove, down to the bed. And then I measured from that point down to the bed. These holes are the same diameter, and this side seal groove is the same distance out from the edge on all of them. So if that point there and that point there are the same off the bed, then that must be vertical in relation to the bed. It's the best I can get it. I can't really think of another way to get that perfectly true. And also, if I'm measuring from these distance, from that distance out from the center line, if I'm off ever so slightly, you think how small the error is going to be when it's back up here. So keep that in mind. I'm using a 3mm, brand new 3mm end mill, 4-fluted end mill. Now, full disclosure, I have already done one test cut, and it come out at about 2.5 to 3 thou clearance off the brand new Apex seals. From the research I've done, that's pretty good. So that's how I'm setting it up. I'll do film a quick run through of one pass. I'm going to do it in a few passes. It would be ideal to do it in one pass, but with a tool this small, it'll break. So multiple passes, probably 3 to 4 passes, and yeah, I'll bring you back when it's done, and I'll show you the end result. That's it. All 3 out to 3mm. No issues. Went well. So I'm going to clean that up, file it, and I'll chuck it up in the lathe, and then we'll do the race clearancing. Alright, so before we put it up in the machine, I want to illustrate the differences in the race clearancing on it. So you can see that, just see that difference in a line there. There's the difference in thickness between there and then clearance at the tip. But this is also thinner as well. So you can do this with verniers if you want, and I just wanted to be a little bit more precise, so I got the mics out. So we're zeroed with the 3-inch mandrel. And yes, I know they're technically metric, but when you start talking about finer point machining, I just personally find working in thou easier. That's just personal preference. Right, so as you can see, we're on what would be the larger section, and if I lock it, so that works out to be 3 inches and 100, and we're at the first graduation, which is 25, so we're at 125 plus 30, 136, 7, we're at 137 thou, so 3 inches and 137 thou. Now, what we'll do is see how much extra is taken off the tip. Sorry, that was 3 inches and 132 thou. Now, if I look at it, and that's 3 inches and 130 thou. So there's an extra 2 thou taken off at the tip on that section there. But if we measure the original thickness, so this is my standard rotor, obviously. A bit tight. There we go. All right, so 125 plus 5 is 100. Oh, come on, focus. 130, and then if we come around to where the line meets, so we are at 134 and 5/10. So we've got 4 thou. Come on, 4 thou off the major, or off this larger machine section, and then what were we? 132. So we've got 2 thou off this. So when I chuck it up, I'm going to machine 2 thou off the entire face, and then I'm going to come through and I'll just measure what sort of circumference this is, and I'm going to machine another 2.5 thou to that circumference. So, all right, I just wanted to show, just to illustrate the difference and give you a specific size. Right, let's put it in the lathe and square it up. Set up in the machine. 4-jaw, just to try and get concentric. 3-jaw just wasn't cutting it. And we've got the face. Let's see if we can get it properly. Get the shadow out of it would be good. Essentially perfect. There's probably maybe 2 or 3 tenths in it, but considering we're going to be taking off, close to 4th hour over the whole thing, not the end of the world. Unfortunately, I can't get my mics in there to measure it, so I'll show you a little trick to use a dial indicator. I don't have a DRO, so I can't do it with that, but we can use a dial indicator set up on the side of the saddle or on the side of the crossfeed, and it'll give us a direct measurement of how far we move across. So we'll set that up and show you what that's about. Okay, so just a nice easy way to get an accurate measurement on your saddle travel. You set him up onto the side. I got it set up on the bed, and then that way you can very accurately see how far you're moving. It's a little bit easier than the graduations on the slide, so that's just a nice accurate way to do it if you don't have a DRO. So we're going to set up. I'll do a test pass, just taking a skim, like not even a skim cut really. I just want to make sure there's nothing sticking out and it's making contact everywhere, and then we'll wind on 2 thou and make a cut. Now you don't go, you only want to cut this face. You don't go into that ledge there. So you just want to machine this face down and stop here. That and the gear don't get touched. Okay, all done. Back on the bench. Now we can do a bit of measuring just for confirmation back with the micrometers. Verniers are fine, but when you're talking tight tolerance, and yeah, 1 thou and 1.5 thou is not what I'd consider a tight tolerance, but it's nicer to use mics when you can. So, like we had out on the tip, out there, so that's 3 inches and 1/30 thou. And on the tip of this one, about 5/10 over. It's, really not that big of a deal. And then the larger diameter, we were, what's that, 132 and 5/10 thereabouts. And this one here, about 132 and 3/10. So yeah, all good. Happy with that. They're now matched. 3 mil. I go through and deburr them. To deburr the grooves in here, I'm just going to get an old side seal, and I'll go through and I'll just make sure they're clear and free and move. Deburr those. I've got some diamond, a diamond file for that, and then the rotors are done. So let's grab the plates, and I'll head down to the local machine shop, and hopefully he can still fit me in, and we'll get the plates ground. Okay, so plate's fully ground, as you saw. Now I thought I'd just walk you through the steps that I'm doing to get the surface finish that I want, which is essentially completely flat and as smooth as I can get it. So this is how they come back from the surface grinder. As you can see, there are, that's a bit bright to see, they're marks. You can sort of just feel them with a fingernail. Just. It is flat. As flat as a machine like that can get. So the big issue with the big segmented disc surface grinders like I was using is they are a big flat disc. And the reason why it's got lines like that is because the heads are angled slightly one way, like by a few thou. And if you can imagine a big disc running around that's angled slightly one way, it's going to cut on the leading edge, and then it'll just come back on the trailing edge. Now what that does is put a very, very slight concave in the surface. When you start talking, cylinder heads and things that are only yay wide, it doesn't make a difference. But obviously we're talking about a big section like that. Now, it's about a half a thou to a thou. I could sort of pull a 1.5 thou feeler gauge through, but there was friction, and so I'm going to say it's probably about a thou through the guts. And plus this surface finish isn't good enough for what I want. So what we're using is some valve lapping compound. Now this is fairly coarse, but it breaks down very quick. So you put a bit on, and I'll show you in a minute. You put a bit on, you start the process. Now I'm lapping plate to plate because that's as flat as I have around here that I know, and so is that. So if I put them both together, and they'll both be high in the same spots, so they'll both be slightly high on the edges, and you can see that here. So I've started this plate already, and you can see it's pretty good through there, but because of the way that the cutter runs, we've got less contact here and less contact here. So they're all high in the same spots. Now, that's what we start with. We come back, we put it down. Now this side has had a little bit more work. Get the torch. So there's just a small amount down there, and the rest of the plate, they're just watermarks. I mean, I'm not at bottom tolerance for the plates, which is 4 thou. So according to the Mazda data, you can take 4 thou off each side. I haven't. They're sitting about 2.5. So yeah, I've still got meat, which is good. But I didn't really want to take any more. I can't feel them. They're just a bit of a discoloration. If I had taken another 1/2 thou, I probably could have got it. But really, this process of lapping will remove it, and I'll show you in a minute. So this one's, I haven't really worked it too hard, but it's already, almost, we're probably talking about 80% of the plate, 85% of the plate has full contact, and you can see through the grade area. This one, as I said, needs a little bit more work, but it's got a pretty good contact patch. Now, this one come up pretty quick, so it must have been sort of the most flat out of all of them. I did this one up against that face, which is why they're sort of at about the same place. And what I did with this one is I got an angle plate, which was over here. So I've got a cast iron angle plate here, and don't mind the paper being torn up. I went 1500 and then come through and removed the marks, and then 2000, that's 2000 wet and dry that's on there at the moment. And it brought it back to a really nice, smooth, effectively imperfection-free surface. And it is flat. There is minor amounts of tooling marks left. It's, what you sort of refer to as a witness mark, but it is completely fine. So it sort of grabbed it all the way down here. It's just an ever so slight low spot there. Really not worried about it. That's just where I sort of dragged the paper as I pulled it off. That plate's done. I'm happy with that. There is no measurable distortion, not that I can measure with feeler gauges, and it's got a really good finish. So this one's ready to be ported and cleaned up. So we're going to clamp this one down so that we can do this face, and then I'll do it up against this face and show you what it looks like. make sure they're clean first. Paste down, and I've been using a bit of WD just for some extra lubricant because we don't want it to cut super deep. We just need to take the surface imperfections out of it. So that plate, said there's just some sections down the bottom and the top that haven't been touched. I'll be careful when you lay these on, lay them flat, like just sit them down gently. And it sounds horrible to start with. Let's see how much coverage we got. Now, what was that? Phone says it was less than a minute, really. We are, So yeah, light run. Get some of the grit off. 2 minutes worth of work, and it takes, you see how flat they are really. I mean, there is, you can just still make out some of the machine tool marks, but you can't feel any of them. But that surface is still fairly rough. I mean, you heard that paste, it's pretty coarse. So I'll show you what I did after that to get it smoother. All right. Pretty simple. Steel angle plate. It's flat, true, and that's 1500. So just put it on there. It's just held on there with a couple of magnets. Bit more WD. Sit it down flat. Be very gentle. I keep lifting it up just to get the WD back under it as a lubricant. Otherwise, I find it sticks down. And yeah, work your way around. Anyway, that's nothing exciting. We just keep working at it like that. Once that's done, 2000, and you end up like the other plate like I showed you. So flat, true, and a really smooth, really nice surface finish. Of course, you know, no idea if it'll work, but that's what I did.